Everyone, just continuing with the same Excel spreadsheet here, moving on to example 2. The systolic blood pressure, or part of your blood pressure, averages 120 with a standard deviation of 20. We're going to assume a normal distribution here. We want to know what's the probability that your blood pressure is between 115 and 125. So this one is a little bit different. So now we're not just doing below a certain value or above a certain value. We're trying to figure out in between two values. So what we could do here is first, like we talked about with the z-scores, we want to find the largest value first, because that's going to be the area below that, and then we're going to subtract out the bottom area, and we'll just be left with the area in between the two values. And so I'm going to label my larger x, my mean, and my standard deviation. And then I have my smaller x, my mean, and my standard deviation. These are the same, but we can write them down anyway. So my larger x here is the 125, which is slightly bigger than the mean, which is 120, and the standard deviation is 20. So now we can also, our smaller value is 115, the mean is 120, the standard deviation is still 20. Okay? So to find the probability that a blood pressure is between two values, what we're going to do is we are going to find the probability that x is less than 125, and we'll subtract from that the probability that x is less than 115. And by doing this, remember the picture over here. Where is it? Okay. When we do the norm.dist function and we find less than, we're finding all of this area here. And so what happens is we find all of the area below a certain value. If there was another value that I wanted to find the area between the two values, then I would also find the area below this new value, which is all the way to negative infinity. And if I subtract the light gray, or the black from the light gray, I'm going to end up with this area right in between. Now I know for this example, we're talking about a different mean and standard deviation and all that, and values. But this is just an illustration of what's happening in this problem. So again, we want to find the probability that the blood pressure is between 115 and 125. So what we're going to do is we're going to do norm.dist x mu sigma true, and then we're going to subtract norm.dist smaller x comma mu comma sigma. I didn't really have to write the mu and sigma twice, but it just keeps things nice and organized for me. And so I have about 0.1974 chance that my blood pressure is going to fall somewhere in that range. Okay, so now let's find the blood pressure that let's find the blood pressure that's less than 130 here. So again, I'm not doing it in between two values. It's just less than a value. So I just need to identify an x, a mu, and a sigma. And in this case, x is 130, mu is 120, sigma is 20. And I'm finding the probability that x is less than 130, which is exactly how the binomial the normal distribution function works. So I don't have to do anything special, just norm.dist these three values separated by a comma, and then a true Again, we talked about this in the last video. The true does the accumulation from negative infinity up to the value. False brings us back to our probability density function from the binomial function. And so it's going to calculate something totally different here. And so we have about a 0.6915 chance that we're going to score, that we're going to have a blood pressure that's less than 130. And so now let's do blood pressure over 180. Again, I'm just setting up x, mu, and sigma. That's going to be 180. Our average is 120. Our standard deviation is 20. So before I even calculate this, I'm thinking this is going to be pretty rare since we're about 4 standard deviations above the mean. And so we go ahead and we're finding the probability that we're 3 standard deviations above the mean. So x is greater than 180. Now that's the same thing that as finding the probability, 1 minus the probability that the probability is that x is less than 180. So this second part, the probability that x is less than 180, is what our binomial function is going to, our normal distribution function is going to calculate for us. So we're going to do 1 minus norm.dist, and I'm going to do x, comma, mu, comma, sigma, comma, true. And so, yeah, that's pretty rare. It's about a 0.13% chance that my blood pressure is going to be over 180. All right, let's move on to a more difficult problem. So the time it takes to knit a sweater is normally distributed with a mean of 4.3 days and a standard deviation of 1.2 days. If I take a sample of 48 people who knit a sweater, find the probability that more than 17 would take over 5 days to knit a sweater. All right, so this is more complicated, but we're just going to bring 2 steps together, and we're going to separate this into 2 problems. First, what we need to do is we need to figure out the probability that it takes more than 5 days to knit a sweater. So we need to find that probability. Well, that's going to be 1 minus the probability that it takes less than 5 days to knit a sweater. So I'm going to set up my x, my mu, and my sigma. In this case, 5 is the value I'm interested in. Mu is 4.3, that's the average, and the standard deviation is 1.2. So I'm going to do 1 minus norm.dist x, comma, mu, comma, 1.2, comma, true. Okay, so now I have the probability that it takes more than 5 days to knit a sweater. It's about 28%. Okay, this is now the P for my normal probability. So I have, remember, I had a different x, but I have my n and my p. And so this is a new x. Maybe we should call it something different. But now, knowing that this is the probability that someone knits a sweater in more than 5 days, I can use that in my binomial distribution. X is, okay, again, I'm trying to find the probability now that x is greater than 5. So remember, that's the same thing as 1 minus the probability that x is less than or equal to 4. Sorry. I messed that up. 17. There's 48 people total, and I am looking for the probability that it would take more than 17, that more than 17 people would take over 5 days. So we have 17 people, we have 40 that we're interested in, we have 48 people in total, and the probability of success, X being knitting a sweater in over 5 days, would be this value here. And so for this part, the probability that I get over 17 people, more than 17 people, is going to be 1 minus the probability that I get less than or equal to 17. So X, number of successes, is 17, comma, the number of trials is 48, comma, the probability is 0.27, comma, and we want this to be true because it's not equal to, it's less than. So we're going to do cumulative. And that comes out to 0.0977. So there's a 9.8% chance that we will find more than 17 people that take over 5 days to knit a sweater out of 48. All right, we'll wrap up this last problem in a separate video, and I'll see you there.